another A-level computer science video with me, Mr Goff, from mrgoff.com. This video will focus on the role of stack frames when subroutines are called. A call stack is a data structure used to store the details of currently running subroutines. That is, all the subroutines have been started but are yet to finish executing. Each subroutine will be represented by its own stack frame, made up of a return address, parameters for that subroutine, and local variables belonging to that subroutine. The parameters are the values that are passed into a subroutine. As an example, a subroutine to draw a square may include parameters for things such as the x and y coordinates to draw it at and the length of each side. Local variables are those defined within a subroutine that exist only while the subroutine remains in the call stack. As soon as it finishes executing, we can no longer access its local variables. The return address specifies which subroutine control should be passed back to when the current subroutine finishes executing. When a subroutine calls another subroutine, the point at which it may be resumed is also part of the return address. Let's take a look at an example of the call stack in action. We'll consider a subroutine drawLogo that draws two offset squares and is itself made up of two calls to a procedure drawSquare that itself consists of four calls to a procedure drawLine. First, drawLogo would be placed on the call stack. Then it would call its first example of drawSquare. This would now be placed ahead of it on the call stack. drawSquare would then call its first example of drawLine, which would be placed on the call stack. Once it had executed and drawn its line, it would return control back to drawSquare, which would then call its next drawLine. This would carry on until it had called all four drawLines. Then drawSquare would be finished. It would pass control back to drawLogo, which would then request another drawSquare because it needs to do two to complete its subroutine. This would then repeat the process until eventually all the drawLines were executed, therefore the second square was executed, and therefore the whole logo was executed. Recursive algorithms are algorithms that call themselves. We'll be learning more about these in the next video. Each successive call to their own subroutine must have a separate frame on the call stack, as it will have different parameters and possibly different local variables. This means, as it unwinds, each result can be popped off the stack one after the next. If there are too many active subroutines and the memory location for the stack becomes full, then you will get a stack overflow error. Stack underflow, on the other hand, is when there is an attempt to pop an item from an empty stack. That brings us to the end of this video on the role of stack frames in the call stack for subroutines. Join me again soon when I'll be taking a closer look at recursion. Use the resources at mrgoff.com to help you revise computer science, and until next time, it's bye for now.